Hello, everybody. Coming together, I'm with Professor Unwin from University of Warwick. And so, Professor, usually students are very scared of electrochemistry. Some of them later on, they start to work with electrochemistry, but at the beginning, they are really scared. So why did you choose electrochemistry at the beginning of your journey? And if you have any suggestion for the new generation that we like to approach with this technique.
Yeah, I think great question, Sarah. When I started at Liverpool University, I really enjoyed measuring things in the lab. I'm not an organic chemist. I can't synthesize anything. My friends will tell you I can't cook. And when I used to do organic chemistry, at the end of the lab session, I used to just have no product, and I just have these big solutions with nothing made, and I would have to hide it in the cupboard. But I always enjoyed data and mathematics, so I enjoyed measuring things. And then when we had to choose a project at Liverpool University, I was really interested in surface science and surfaces. But then I heard that students who were doing projects in surface science, they were spending the whole project period waiting to get a vacuum so that they could study this surface in pristine conditions. And then I was talking to Richard Compton, who was an academic at Liverpool at that time. And he was saying, oh, the good thing about electrochemistry is it's surfaces, but you get data very quickly, and there's also mathematics and fluids and modeling and this kind of thing. So it sort of seemed like it would really appeal to me. And I think, the first couple of days I did electrochemistry research, I just really enjoyed it. And then, as I said to you, I think before, I also like the history of electrochemistry. I think it's really fascinating. So I think, in terms of getting students engaged, I find when I'm teaching electrochemistry surfaces, and my colleague Julie McPherson also teaches, we like to sort of emphasize the practical aspects. I also like to provide some stories about some of the scientists, because I think people like stories, and show how useful it is. Because I think it's a beautiful subject, but I think it's also a very useful subject. So I think to try get students in through the applications is a good thing.
Okay.
Yeah.
Faith. Okay. Then next question. So from Beatles, with the little help of my friend, to everyday life in the lab. So how important is network in the lab, and how we can create a great atmosphere and a great team, especially nowadays that the competition, even in academia, is so high.
Yeah. So I think our group, and I say our group, so we try and treat the group as a whole entity where everybody contributes. I think is really important. It was most successful during this period of the 2010s up until the pandemic period during that decade. And at that time, we were very diverse in all aspects. So very international. We have a very good balance between male, female, and diversity in all aspects. And I think that helps to really create a very vibrant atmosphere where you have lots of ideas that come in, but also like a lot of cultures that bring in the other perspectives as well. Because I think it's not just about doing the science, but it's about people learning from one another in other ways as well. And we were also very diverse scientifically. We had very good students who studied their first degree in mathematics or computer science or physics or biology with chemists.
Yeah.
And I think that makes it quite exciting, because then everybody's learning from each other.
Yeah.
And I think if you can learn from one another, it just makes it more exciting. Discovering together.
Yeah.
So if we can make more diverse teams in the future, and more collaborations, I think, would really help, especially after the pandemic.
Yeah. Okay, thanks. Okay. And last, I have to do it, so...
You don't ask it?
No. What's the future of nanoelectrochemistry?
Future of nanoelectrochemistry? Well, that's a good question. I mean, it's hard to predict what might happen. But nanoelectrochemistry, if I may just spend a little time, it goes back right to the very beginning of electrochemistry after Volta's discovery, invention of the pile. And there was there's a British scientist called William Hyde Wollaston, who in 1801 made the first nanoelectrode or microelectrode. So it goes back a long way, and I think it hasn't really taken off for a long time because it's quite difficult to make nano tools and do nanoscience. But now I think the future is very bright, because We have a lot of very robust tools. And I think the future will be that it will be adopted by more groups. They will see it as becoming more a core part of what they do. And then hopefully there'll also be more involvement from mathematicians and computer scientists, because we're going to be generating a lot more data with this kind of technique. Yeah. Okay.
Thank you.
Okay, no, thank you, Sarah, for your questions. I enjoyed it very much. Thank you.